got out kind of late.
Alright, what we're going to hand out right now, I'm going to hand out your test that you took last week. We're going to go over it. We're going to go over every answer so you see it. You have 1 week from today if you choose to retake it. Now, you don't need to email me. You don't need to talk to me. If you're going to retake it, you just show up in the morning, and we go through the process. You have to fill out paperwork if you're going to retake it, so it kind of checks off what you've done. You know, did you do all your homework, all that easy stuff. What were the problems that you missed? It's pretty self-explanatory. Okay? All right, so I'm going to hand these up. You do not get to keep these. They are mine. I'm going to collect them at the very end of doing this review. So you get to know it right now. Alright. Okay, everyone got their test in front of them, except for Paige, who isn't here yet. Alright, let's take a look. I'm going to hit the lights. We're going to go through each problem just to make sure you know what you missed, why you missed it, why you agreed in a certain way, all that good stuff. So we'll go through it here in a second. Hopefully the projector actually works. Alright, vocab terms. Silly mistakes that I saw. People using words more than once. Not very smart. Alright, because I told you were going to use a word once, crossed out. Okay, test out of 60 as you saw. Vocab terms, that is 7. How I basically grade this. Every two words is a point. Now, if you did this weird situation where you missed, let's say you missed 3. That's 1 point for these, and there's 1 point for that one because I don't do half points. So, yep, you got burned on 1 extra word. So that's how it works. But it's every 2 for sure. So if you would have missed 1 more, you would have had a freebie there. So, so it's every 2 words you get a point, unless you have that weird situation where you missed 1. Okay. All right, Paige, I need to get you your test. Here you go. We're just going through. We're just starting. So let's go through the vocab words. Okay, a line with 2 endpoints and all the points in between is a segment. It has 2 endpoints. That was the key word. So a lot of people put line there. Oh, it's a line. There's 3 types of lines. Ones that have 2 endpoints are called segments. Okay, an intersection is where figures contain the same points. It's an intersection where they're sharing the same point. That was a quote-unquote book definition. That was not my own. It was exactly out of the book. Okay? Interior points connected by segments that cross the edge of a polygon, so it's a type of polygon. So that's concave. Set of all points in space, that was on your practice test. Vertex, common endpoint of 2 rays. Equiangular is angles that are all equal. I had somebody put equilateral there. That's maybe one of the words. Good way to fail that one. All right. Exterior points are points that lie outside the angle. And a measure of an angle that is exactly 90 is right. That is not complementary. I know a lot of people are like, well, if you say complementary is 90, it's when 2 angles add to make 90. This is saying 1 angle is 90. That's right angle. Complementary means you have to add 2 of them. There's 2 angles there. Set a measure of an angle. Subtlety of words. Bisector is something that cuts something in half. It's an angle bisector. It doesn't even matter what type. Complementary is the sum of 2 angles is exactly 90. Collinear, points that are contained on the same line. A lot of people thought that was an intersection, but there are multiple points. Intersection is only where there's 1 point crossing. Okay? This is points contained on the same line. That has to be collinear. They're right on top of each other. Congruent are figures that are the same size, shape, and measure. That I believe that word and the right angles were on the previous test, the practice test, I mean. A figure that contains that continues in both directions without limit, that is a line, because there's no endpoints. And a midpoint is a specific point that lies at a geometric figure's center. So there you go. There's all your words. Remember, it's every 2 words that count a point off. If you happen to miss, let's say you missed 3, then it was 1 point for that one and 1 point for those 2, because it was just the way it works. I don't do half points. So you got burned by 1 word. Okay, let's move on. Okay, number 2, you had to name figures. For the love of God, a line only has 2 letters. Stop putting 3 or 4. Okay? If you're naming an angle, you use 3 letters. If you're naming a line, it's 2 letters, or you have to use the cursive one. This is a cursive letter. That's a cursive letter. That's a cursive letter. You could just use 1 letter. That is not a point. Okay? It's just the name of the line itself. We talked about it in class that this line is literally poking through the paper straight down. It is not on it. Okay, so name a line that's only in plane B. The only lines that are actually on this little flat surface is this line and that line. This one pokes through it. It's not actually on it. So it's line M and N. Or if you did the 2-letter situation, which a lot of people are failing at, you had to go like YW or YR or XR. And a lot of people said XR instead of YR. That's fine, but you have to use 2 letters and you have to have arrows above it. Those are lines, not line segments. It's a big deal for me. I count them wrong if you put the bar above it. Okay. Name a line that does not contain on plane B. That's line L, like I just said a little bit ago, or RZ if you want to call it that. Name lines. So these 2 are requiring that you name 2. So name 2. Name lines that are on that hit point R. So lines that hit point R, YR and RZ, or what I name them is line L and M. Those are the 2. Okay, so it's just how you look at it. They have to hit R. And somebody tell me points. It's not even asking for points. It's asking for lines. Name the intersection of M and N. So here's M. Here's N. That is literally point Y. It's not line Y. It's not intersection Y. It's point Y. That's kind of spot. And then name another, or what is the other name for line N? The other name for line N is YW, or if you switch mine to WY, but you have to have arrows above it. That's a big deal. Basically, you got a point for if you give me the correct item and it's written correctly. Yeah, I'm that picky. Okay, let's move on to the next page. Okay, at the top. I believe no one missed the top. I don't think. The only one that some people went like a little bit too far. It was right in between. It was like 5.7 or 5.8. It was right in that mid-between, so I don't care if you were in the middle of that, that's fine. I had a lot of people put like 5 3/4 or 5.75, that's fine. It was just somewhere in that range, so I was accepting anything. You had to be close. I had somebody give me millimeters, not a big deal, I didn't count it wrong. It was just like the first centimeters, because that's the rulers measured in. Alright, let's go to number 4. Some people were skipping 4. I would not skip 4. It's worth a lot of points. Hey, there we go. All right. All right. So number 4, you had to draw the picture. So here's my pictures for each of them. So this is X, Y. That was Y, Z, because they said Y is in the middle of X to Z. All right. So here you go. Here's 7A. There's the 5A, and the whole stick is the 6A plus 24. So you add these 2, and that makes the whole stick, which is that. This makes 12. You subtract the 6 over, you make 6A. So it's 12A minus 6A, which is 6A. You divide by 6, you get 4. You have to plug it back in to one of these, because what do they want? They wanted the value of the variable and that, YZ. You had to plug it back in here. That is YZ stick. Plugging the 4 back in, that's 5 times 4, which is 20. Okay, a lot of people forgot to plug it back in. That was the exact problem out of your book, and I even said you had to plug it back in on test day. Okay, then I had Y in the middle of X towards Z. You had 11D, you have the 9D minus 2, and the whole thing, when you add these together, makes the 5D plus 28. That is X to Z all the way. So you add these 2 equals the 5D minus 28. So this makes 20D. You add the 2 across, making 30. You subtract this over, making 15. You divide by 15, you get 2, and you have to plug it back in there because you got to find YZ. Plug in 2 in here, that's 18 minus 2, which is 16. There you go. So there's your 4 points. It literally, there's 4 lines of work, as you can see there. And a lot of people skip them. I was going to skip those. So, not bad. All right. Number 5. You have to find just the distance. Not a midpoint. I didn't say midpoint. Find the distance from J to M. You can count with your fingers. 1, 2, 3, 4, 5, 6, 7, 7. Some people were failing at that. They were reading 3.5. Not trying to do it. Okay? M to P. 1, 2, 3, 4, 5. It's 5. It's 5 steps. 0 to 5. It's literally 5. Or you can do my little formula here where you find distance. Okay? 2 points each. Okay, on number 6, I put both methods of approach. So if you're in that camp where you do the Pythagorean theorem to find the distance between these, you go down 3 over 7. So this is your Pythagorean theorem. 3 squared plus 7 squared equals your c squared, which is the distance. This makes 9. That makes 49. You add them together, you make 58. You take the 2 over and make a square root symbol. That was what we talked about. This is roughly 7.6. Not 8. 7.6. That's the closer number. Don't round that far up. It is not 8. I had somebody tell me that that number was the number 2. Somebody honestly told me that the distance from R to S is 2. That is failing on such an epic proportion that I can't wrap my head around that. 2. This is 2. That's 1. So I like to make fun of people, so don't take it personally. Just that was bad. That was bad. You'll learn from that one. All right. So subtracting the numbers. So -4 minus the 3 that makes a -7. But when you square it, it makes positive because negative times negative is positive. And I think that's maybe where they're wrong. It's still bad. All right. Anyway, 3 squared is 9. When you add them together, you make 58. So that's like doing the distance from over there. And yes, that does make 3. It's 2 minus -1. There you go. That was out of 4. All right, moving on. Gives me my brain to think about how much you get that from. Moving on. Number 7. Some people did not read the instructions. In fact, I even underlined it here. So you could see this. I wanted the midpoint of each stick. That is literally drawing it. I drew it there and I got at least closer than some people did. Just drawing a line and pointing an arrow at it. That's roughly where it's at. But you have to give me the coordinate. You can't just eyeball it. Somebody literally just drew it. They're like, yeah, it's right here. Yeah, you gotta give me the number. So, alright, so to do it, you add the x's together, which are these numbers, and you divide by 2. So that's -1 divided by 2, which is, 1, you add those together, and you divide by 2, which is half. If you add the y numbers together, and you divide by 2, that gives you the middle number, which is 3.5. So it's over half, up 3.5. That's literally where my arrow's pointing. Okay, it's the middle of the stick. I can guesstimate that. All right, on the other side. Okay, on the other side, same exact idea. I'm trying to figure out roughly where the middle is. This is roughly where I thought the middle was going to be. Somewhere in that range there. So you add the x's together, divided by 2, so that makes 4. -4 divided by 2, that's a -2. Okay? And 5 plus -5 is 0. And you divide that by 2, you get 0. So that's over 2, over -2, I should say, and up and down 0, which is, that is the exact number. Because they jump by 2s, not the picture. Okay. Questions, comments, concerns on anything so far? I think that's the first half of your list. Moving on. 8. There are some epic fails in this one. Number 8. Okay. You have the name of vertex. A vertex is a point, is a coordinate, like a point, dot. It's not an angle, it's not a line. So if you're putting an angle or a line for a vertex, not thinking about it. All right, so angle 4, that is right here. What's the letter I'm pointing at? Hey, that's the answer. Q. Q, right? Point Q. All right, name the size of angle 3. I had somebody, honestly, the sides of angle 3. Sides of angle 3. That's pretty angle 2 and angle 9 are the sides of angle 3. These over here, 2 and 9 are over here. And no. So, no, I'm looking for sides, not angles, so didn't read that problem really well. So name the sides of 3, that is this wall right here, and this wall. So that's going R to Q, or R to T, or R to P, whatever you want to call it, okay? Those are walls, they're rays. That's what I'm looking for. Name another angle for angle 2. Angle 2, well this is the name of it. This, right? This object. So that is N, R to N, or N, R, V, or going backwards, V, R, N. But it's literally these letters. And that's how you name an angle. Okay, I had a lot of people telling me that it was like crazy. I had a lot of people saying like it's angle R. You can't just name angle R. There's 5 angles coming off of R. There's actually 6 angles coming off of R, isn't it? 1, 2, 3, 4, 5, 6. There's 6 angles coming off of R. So you can't just say R. You have to give me the 3-letter system. Okay? This is how you do 3-letter systems, by the way, not this. What is that object? Like, if I put that above it, what is that? Nope, it's not a line, so you failed in both accounts. Because lines only use 2 letters. So, not a line. It's nothing. It's literally wrong. So if I saw that, I immediately got it wrong. I didn't even look at your letters. It's just wrong. Very bad. That's how you do an angle. You have to put an angle symbol. Okay, name a linear pair. Now notice I wrote random. There's random answers here. There's like, it's so open-ended, you should not get it wrong. A linear pair are 2 angles that make a straight line, not lines themselves. I had a lot of people doing this. Oh, a linear pair. SR, the line, and another one. PQ, a line. No. Linear pairs are angles that add to make a line. So here's one. This angle right here and this angle. Because when you put them together, they make a straight line. So I could say, like here's a random one, angle 5 and angle TPQ. That's that one because there's no letter there. So TPQ. Or 5 and 7, they're right next to each other. Maybe that's a better way to do it. 5 and 7, right next to each other, make a linear pair. And they have to be, it's an actual angle that makes a straight line. I had a lot of people give me angles that were not even close together. Angle 2 and 1 added together. No, 2 and 1 are even close. Okay, linear pair, they had to make a straight line. Now, vertical angles are angles that are across from each other. These are vertical angles, by the way. This angle and this angle. Do you notice they're like a little funnel system? It's not this. Here's an angle and going this way. That is not a funnel system. That funnel is broken. It's like thin. So that's not a funnel. Okay? Because I had a lot of people telling me that acute vertical angles, angles 3 and 9, your funnel is broken. It's going that way. It's making like an L shape, not a funnel. So if you had letter R in it, you've already failed. I just counted it wrong. You had letter R as the middle of vertex. Because R has no vertical angles coming out of it, basically. Okay? You'd have to use, like, vertical that are acute. I would do vertical angles that are small. This angle here and this angle. They're small. They're less than 90 degrees. So angle 5 and the angle that's right below it. Or this angle up here and this angle that's below it. Those are vertical. They're like the funnel towards each other. I had a lot of people telling me 6 and 8. 6 and 8 don't work. They're obtuse. They're not even acute. 8 is a really, really big angle. 120. Okay, so you had to give me angles. You had to use 3 letters with a little arrow symbol up. Or you give me the numbers. Alright, moving on. 9. Did I tell you that those objects are at 90 degrees to each other? No, you can't assume that. You cannot assume that, because they are not, in fact. So I didn't tell you that. They're actually slanted, just a hair. Your eye cannot differentiate less than, I think it's 2 degrees measured. So that is almost 90 degrees. It's like 88. So it's close. Here's how you do it. You add these two together, set equal to 180. They're a linear pair to make a straight line. You add the other two together, and you set it equal to 180, because they make a straight line. This way, you're not assuming anything. They make a straight line. Those are lines. So, you had the 2y plus 50 plus the 5y minus 17, set it equal to 180 like I did. I added the numbers, I added the y's, I moved the 33 over, I divided by 7, I got 2. I did it the same for the x's, which you can't see, I got cut off, but it was 7x minus 248 plus this equals 180. You can see my work there, where I added the two things together, and I moved the 204 over, and I divided by 8, and you get 48. That's how you do it. Good, and the last one. By the way, I had some people not even attempt this problem. That is a lot of points missed. Number 10. 1, 2, 3, 4, 5, 6, 7. That is an E-center figure. That is an octagon. Octagon is 8, like an octopus. Right? It is irregular. Here's the reason why. Now, it looks like it's regular. A lot of people put regular, but here's the problem. Are these angles right here same as these? No. This is a tricky question. Anytime your picture is concave, it's automatically not regular. Automatically. Because the angles on the inside will be too big. I was trying to see who actually read their textbook. The textbook actually says if it's concave, it's not regular. Pentagon, that picture is regular. Every angle, every wall's marked. Every single one. That is a pentagon. There's 5 walls there. It looks like a house. It is convex, not concave. So do you see the differences? These angles weren't marked. Those are the big ones. Okay. You can see your score. You have 1 week from today if you wish to retake it. You don't need to email me. You don't need to talk to me. You can just show up in the morning. We review the problems you missed. I put examples on the board if you need one to make sure that you know how to do it. And you will take a completely different test if you're going to retake. It is not the same test. It is completely new. New vocab terms, new pictures, everything. New numbers. So you have to really understand, you really have to know what you're doing. It's not one of those things you can just memorize what you did wrong. I don't do that. I'm testing whether you can understand this. Okay, makes sense? These are already in grade book. So, all right, I'm going to walk around, I'm going to collect them. They are mine. You will eventually get them. And keep them in case somebody actually wants to retake it. So usually I hand these back within a week. You can actually keep it forever. Okay, I think I got everyone. Good. All right, so there you go. All right, let's talk about our next topic here today. All right, now I know we had homework due tomorrow, so I'm going to give you a little bit of time to actually work on it today because I know a lot of people were stressing about it yesterday. So I'm going to try to give you a little bit of time here. I'm going to intro what we're going into next, which is basically tomorrow and Thursday. Okay, the section we're going into. Up here. We're going into chapter 2, which is called Deductive Reasoning. I'll explain that term here in a minute. But the title of your section, like chapter 2 altogether, is called Reasoning and Proof. This is basically what they're testing. It's called deductive. I'll give you that definition here in a second. And I'll even give you an example of what deductive means, like to the extreme end. Okay? Alright, this is just a brief intro. Again, I'll post these slides online tonight so you don't have to stress about it. Alright, but let's talk about these words here. Okay? so we're in section 2.1. Now there's two things. I said earlier, deductive reasoning, right? There's another term called inductive reasoning. These are the two types of reasoning that most people have to have. You wouldn't be in this room unless you didn't have these. There's literally no way you could have made it here. Okay? Deductive reasoning, which we'll go through here in a minute. I'm going to give you the most brief, like generic description I can give you of deductive reasoning. Deductive reasoning people are people that are just and only book smart. You probably think of somebody that is only book smart. They have no common sense whatsoever. That's deductive reasoning. They can memorize things. That's about it. Okay? Inductive is a complete polar opposite. These are the people that are not book smart. They do not memorize anything. They can't. But they are so street smart, they can solve the most complicated things. You can probably think of somebody that pretty much fails every class, but once they take a standardized test, right, like a MAPS test, or they take a state test, like what is it, ITDS or ITED, they get 90 in everything. It just makes you upset, right? They're inductive reasoning. They're like 100% inductive. Complete polar opposites. Most people have a mix of both. Whether you believe it or not, some people have to have both, because most people can like memorize how to get here, but you have to adapt to situations to get here. Like that's where inductive reasoning comes in. You can make judgment calls when you're driving your car, like whether you should stop or slow down because of traffic in front of you. Deductive reasoning people that only have this wouldn't slow down. They just know how to get there and they're going as fast as they want. Okay? Because there's no limits. They don't understand how to adjust to any situation. Okay? Now let's talk about deductive, like the more correct definition. People who are purely inductive reasoning, if you think about them, the people without common sense, they can memorize facts, rules, definitions, formulae, theorems, postulates. Okay? This is what they memorize, and they're really good at it. People are really good at like vocabulary, are really good at this. That's why I put it on the test. You need this. It is actually a good thing to have some memory. Okay? Some people have like quote unquote like photographic memory. They can memorize after just kind of looking at a couple of things once. It's a skill. You can develop it. Can't teach you how to do it. You can develop it over time. If you read enough things, you can actually get that skill. Like how many people in here, honestly, like if you were to think back into other classes, maybe not this class, but other classes, you can recall like if there's a word on like on a homework, you can kind of recall roughly where it's at in your notes. You're like, oh, I remember kind of it's at the bottom of the page. I remember covering that. Or you remember like a certain picture in your book. Oh yeah, I remember that when we talked about that. I had a picture of a frog at the bottom of the book. You're doing deductive reasoning. You have some type of photographic memory. You're memorizing where it's at on the page. Okay, but these people that only have this can't even adapt anything. I can give you the best example of this ever. I can go through 20 problems on the board of teaching you how to do this. Right? I can teach you how to do that. And I can do 20 problems of it. Where I say, oh, you have to add 4 to this side, or you have to add 4 to both sides. But the minute I give them this problem, they can't do it anymore. Because now that comes different. It's not adding anymore. They'll try to subtract 3. Because they have no inductive reasoning. They can't adapt. They can't see, like, the whole point of this problem was to learn that you have to do an opposite. They can't even adjust to it. So when they get to this problem, they just fail it every single time because they don't realize, oh, I'm supposed to do an opposite and divide by 3. They can't even like make that connection. And you can think of it. That person that they go through notes and then the first homework assignment they get, they're asking 50 questions on it. How do you do number 10? How do you do number 11? How do you do number 12? You have 0 inductive reasoning. You can't even adapt. You can't even adjust to your problem. And I have no patience for those. I understand. I need to get better at that. But I don't. Like, you just ask me 20 questions over the last 20 problems. Okay, I'm not going to help you anymore. I'm cutting you off. Okay, but this is good to have. Don't get me wrong. Like, in this class, you have to memorize formulas. You have to memorize theorems and postulates. These are definitions and properties, right? There's certain things you have to memorize. Okay? Now, inductive reasoning, the person that's on the complete polar opposite of that scale is street smart. Okay? They can recognize a pattern. They can do observations and learn. They have common sense. This is a skill you cannot teach. Like on the other one, you can develop it over time. You can develop deductive reasoning, like book smart. You can develop that by reading more, or studying more, or taking more time. Not just cramming the night before a test. That's not studying. Okay? I'm talking about long term. You read your book every day for at least 10 minutes. You study your notes for 10 minutes every single day. You will eventually learn over time. Okay? Studying the night before, you're not doing long-term memory. You're doing short-term, which goes away in like an hour. So that's why you can't pass a test and cram. They tell you to study long-term. Right? Inductive reasoning. You can figure out a problem without me having to explain it. Most people can do this. All of you have this at some point because you have been able to adapt to different problems. You know, I can put that problem back on the board that I had up here, right? But somebody that has inductive can do this problem as well. That's inductive. I didn't show you how to do x plus 8 equals 12. I showed you x minus 4 equals 10. The person that has deductive can do this problem from now on. Not this one. This one has different numbers. They can't even do that. They can't even attempt to start it. Inductive reasoning can. Like most of you know how to do this because you learned it over time. How many people have ever seen me put this on the board before? Have I wrote it in this class yet, other than right now? No, but how many people can solve it right now? Raise your hand. You can solve it. Yeah, you have inductive reasoning. Because I never taught you how to do it, but you know it. And I'm betting on no teacher has ever written up that on the board. You just know how to solve it. You know the process. That's inductive. You have an adapting ability. Everyone has to have at some point inductive. Now, what I'm about to show you is the complete, like, polar end spectrum of inductive and deductive. I'm going to show you what I call superhuman ability. And this is defined by one word, and it is based on the word savants. They are people with extraordinary ability. And I'm going to just show you one gentleman. He's in England. He's about my age. Okay? He's a math professor at Oxford right now. And he's my age, and he's considered to be the world's smartest man. Beyond Stephen Hawking, right? Stephen Hawking's that super physicist that's in a wheelchair because of dilapidating disease. I'm talking this. Let me bring up the video. All right, so I'm going to show you this. Okay. Forget this gentleman's name. It's Daniel Tammet. Okay, if you watch this video, he's British, he's got terrible teeth. Just ignore it. But Daniel Tammet has an extreme ability where he can memorize things he looks at. So, one of his skills, and he's proving right here in this video, if I had volume to it, he can calculate huge calculations in his head, like really fast. So what they're having him do is divide crazy decimals, like 5 decimal places in his head. Question. Oh, yeah, if you need to go for foods, that's fine. Okay, so they have him calculating huge numbers in his head. That's a skill. That's an inductive skill. That's a rare thing to have like that extreme case. But what Daniel also did is he set the world record for the places of pi. Okay, pi's up here, right? I think there's 25 numbers up here. I think in this school, I think it's Ryan Myers has up to about 50 somewhere. Where he's memorized 50 digits of pi, right? Daniel Tammet memorized 100,000 places of pi. And he did it after reading the page once. He can read a page and instantly recall the numbers. He can read a book and have every page memorized after reading it once. That's a superhuman power. That is a savant. There are certain people in this world that have this weird deficiency. It's not even a deficiency in his case. where they can memorize things. He has little quirky tics and stuff that he does, like little hand gestures and stuff. But he can do superhuman calculations, like otherworldly calculations. Okay? And he explains how he does it. He sees, like what you're looking at here with that headline. He explains that in his head he just sees shapes, and the shape is associated with a number. And he's figured out when he sees the shape and he tries to explain it, he tries to draw it for you. He tries to describe what he sees. So when somebody says, like, hey, Daniel, do 23 times 75, he just sees blips peer into his head. It's just like piercing, blinding light. And he picks out the shapes and he just says the numbers out loud, and that's the correct answer. It just comes out of him. Okay? He doesn't control it. He just throws it out there and he knows it. Okay? And he is currently, on what you're seeing here, he knows like 8 to 9 different languages. So they challenge him. He's like, well, this is fake. He knows things ahead of time before we get there. Somebody's tipping him off. He's just doing these calculations. So what they did is on this is the Discovery Channel, by the way. Discovery Channel challenged him. They said, okay, if you're really good at learning languages and memorizing things, we're going to give you a new language to learn in less than 1 week. A brand new language you've never heard of before. And you're going to go live on TV, and you're going to be interviewed in that language, and you have to answer questions to see if you can actually legitimately do it. So, he did. You're actually seeing the interview here. The language that they gave him was the Icelandic language, which is one of the hardest languages in the world to learn other than Japanese. It has a super, like, crazy amount of dialects. There's a bunch of different forms of Icelandic language. And he went on, I think it was 5 days later, and he went on, they interviewed him, and in fact, after the interview was over, the broadcaster said, he probably knows the language better than I do. He was answering questions in different dialects, adjusting to what I was asking him. And that's way better than anyone else that I know that was on, actually in Iceland. He learned it in 5 days. He read like 9 to 10 different books and he figured it out. Okay? So now what he's doing is he's proving this like crazy calculation of pi. And his goal was to memorize up to 1 million places of pi. So I think at the time he did it here, it took him 8 hours. He recited the first 22,000 places. He knows up to 100,000. So he recited. And all they have 5 people checking him, and he's just saying the numbers out loud that fast. And they're just checking with a pencil to make sure he doesn't make a mistake. He did it for 8 hours. And he wasn't wrong. Because he read the page once. Yeah, that's a savant. That's crazy that this man, this kid, actually has both ends of the spectrum. He can adjust to a situation, which is inductive, but he also has extreme deductive, where he can memorize things. Most savants do not have that. They're very dilapidated. Like, there's a couple savants that actually live in Clear Lake. They live at the Opportunity Village. They have extreme memorization. Okay, but they're also dilapidated. They can't just live a normal life. They have to be cared for by specialists and stuff. But they have skills. Purple is one of them. If you know Purple, he goes to all our sports teams. He has some form of savantism where he can memorize sports and stats. He memorizes everything. He knows every stat about every kid that he watches. He has it memorized. He's got some form of that. So, it's the most insane thing I've ever seen. But it was just like one of those things, I wanted to show you this. It's something that a lot of people will never get to see. They'll never get to see this. There's another gentleman I was going to show you here. His name, but the movie Rain Man is based on it. If you've ever seen Rain Man with like Tom Cruise, it was back in the 80s. And he just recently passed away, but he was interviewed by Jay Leno, Dave Letterman, and stuff, and he memorizes everything as well. And he had such a crazy memorization. He could read pages of a book in seconds. He just like flips, and he can go through a book in like 7 minutes. And he has it memorized. He can recall things. He can even tell you what the story's about. Like it's just certifiably insane. I've never heard of that before. But he can just go through a book. And so they test him on Dave Letterman, where they just called a page. The crowd yelled out a number. They called out a sentence, and he recalled exactly what word it was. Like extreme memorization. And they can keep going from there and just pick up right where that sentence was and keep reading, even though the book is not in sequence. Like just nuts. And I just thought it was kind of cool to see this. Okay. All right. today. You have the rest of the time. It's not a lot. Tomorrow, I'll give you time where you can work on your homework, but that assignment's due in class tomorrow, so I'll give you a little bit of time to